All right, this video is going to go over the key for 11.1. It's out of 29 points. It's half a point for each coefficient and then 1 point for the atom inventory. So you should have 1, 1, arrow, 1, 2. Once again, 1 is understood, so if you have it blank, that's fine. You just can't have a 0. All right, and then 1 point for the atom inventory. Number 2, 1, 3, arrow, 2. Once again, these are worth half a point each. Atom inventory worth 1 point. Number 3 is already balanced, so 1, arrow, 1, 1. Work is worth 1 point. Number 4 has a hydrocarbon that has an even number of carbons. 2, 19, 12, 14. Half point for each coefficient, 1 point for the atom inventory. Number 5, 1, 6, arrow, 2, 3. Number 6, 3, 2, arrow, 1. Number 7, 1, 11, arrow, 7, 8. You don't want to double this hydrocarbon because it is an odd number of carbons. Next problem, 2, 25, arrow, 16, 18. Number 9, 1, 3, arrow, 2, 3. And then the last one, 2, 1, arrow, 1, 2. Please make sure you have a score out of 29 and keep it for the next time I see you. Now what we're going to do is look at word equations. Word equations are really important because we learned nomenclature in chapter 7 and the nomenclature section, right? And so we want to make sure we are going to apply this information. So the first thing we have to do is look at some definitions. A word equation describes a chemical change using the names of the reactants and products. So then we might have a skeletal equation. A skeletal equation is a chemical equation that does not indicate the relative amount of the reactants and products. So in other words, it's not balanced. So we translate the words to formulas. It's not balanced. Okay, so for example here's a word equation. A word equation has words, right? Water yields hydrogen and oxygen. So how would I write the formula for water? That would be H2O. Hydrogen is H, but remember it ends in GEN, so it has to have a 2 after it. It's a diatomic. Oxygen is O, right? Ends in GEN, diatomic, right? So we talked about yesterday, we got to make sure that we have the right formulas. If I fail to recognize that these two are both diatomics, I'm not going to have the right formulas, and that's going to get me the wrong answers for balancing. Okay? So this is a skeletal equation because it's not balanced yet. All right, now we're going to practice with word equation examples. We're going to write a balanced equation for the reaction between chlorine gas and aqueous sodium bromide to produce liquid bromine and aqueous sodium chloride. So the first thing is we write the word equation. When it comes to the word equation, you want to make sure that we only have words. So the first one, right? There's a reaction between chlorine gas, aqueous sodium bromide, and it produces liquid bromine and aqueous sodium chloride. So I've also circled the states of matter, which we don't need. There were no states of matter up here. So I'm going to write what the substances are. So the reaction between chlorine gas, so I'm going to write chlorine, and so a plus sign. Aqueous, I don't need the state of matter for the word equation. sodium bromide, to produce, right? To produce means that I put my arrow to produce liquid bromine. I don't need the state of matter, so I'm just going to put bromine and plus sign. Aqueous, I don't need the state of matter, sodium chloride. So over here I put sodium chloride. That is my word equation. Number 2 now says write the correct formulas for all reactants and products. Include states of matter. So now what I'm going to do is translate what these mean in terms of formulas. So chlorine. Remember, it helps if you have your periodic table out so that you can look at the information on if it's a diatomic or not, right? So here's Cl, it's on the elbow. It's one of my 7 that are diatomics. It ends in INE or GEN. So if it ends in INE or GEN, right, they're diatomics. So we can't fail to recognize those, right? That's going to be big on your homework. Make sure you recognize the diatomics. So chlorine is going to be Cl2 plus sodium bromide, right? So we know our 5 types. If you need to make sure that you know your nomenclature flowchart, you should have that out, or you can maybe look at your phone. I did tell you guys to make sure that you have your flowchart, right? But this is metal plus nonmetal, right? So when I have metal plus nonmetal, that's an ionic compound. So I need to have my charges. So here I have my flow chart, right? So I know that I have metal plus nonmetal, which means it's an ionic compound. Metal plus nonmetal, I need the formula, find the ions, reduce crisscross. So I'm going to do that. Sodium, right, is Na. It's going to be 1 plus. So I have Na 1 plus. And bromide, Br here is 1 minus. Br 1 minus. When I reduce crisscross that, that's going to be NaBr, right? Over here, this is my diatomic, right? So that's just Br2. Sodium chloride is metal plus nonmetal. So I have to do, figure out the ions, reduce crisscross. I have Na plus, Cl1 minus, right? So that's just going to give me NaCl. Okay, now it says write the correct formulas for all reactants and products, include states of matter. So now I'm going to put the states of matter with it. So I have Cl2 is a gas, so I put G for gas. Aqueous sodium bromide, so I'm going to put AQ here. Bromine is a liquid, so I put an L here. And then NaCl is aqueous, so I put AQ. So this is number 2. Number 3, I'm going to use a different color to use coefficients to balance my reaction. So I'm actually going to use this blue color, okay, to balance. I'm going to do an atom inventory. So I have Cl, NaBr, Cl, NaBr. Here I have 2, Na is 1, Br is 1. Over here, Cl is 1, Na is 1, Br is 2. So I want to balance, right? I can go ahead, and there's no H's and O's in here, so I can start with anything. I'm going to start with the Cl. There's 2 here, 1 here, so I'm going to put a 2 here. That changes Na and Cl. So I cross those out. I look up here. Now I have 2 Cl's, 2 NA's, So I did that to get the CLs balanced, but now the NA and the BR are not balanced. So I'm going to put a 2 here, cross this out, cross this out. Now this is 2, now this is 2. All right. So now they're all balanced, and I have completed problems 1, 2, and 3. Your homework is going to be just like this, right? I expect to see work. If it's ionic compound, write the ions, reduce, crisscross. Some of you are going to just have the final answer. That's not good enough. Expect a quiz on word equations, so make sure you know how to do these problems, okay? So let's look at the next one. Write the balanced equation for the reaction between aqueous aluminum sulfate and aqueous calcium chloride to form solid calcium sulfate and aqueous aluminum chloride. So now, once again, I have my nomenclature flow chart, and I'm going to make sure I first just circle what I'm focusing on. So it's a reaction between aqueous aluminum sulfate, aqueous calcium chloride to form solid calcium sulfate and aqueous aluminum chloride. So remember, I can have any of these types of substances, so it's important that I know this flow chart, right? So I'm going to write the word equation first. So aqueous, remember, I don't include the states of matter for the word equation. I have aluminum sulfate, so I'm going to write aluminum sulfate plus aqueous, remember I don't need the state of matter, calcium chloride, to form, so I put the arrow, I don't need the state of matter for solid, so I have calcium sulfate, and I don't need aqueous, aluminum chloride. Okay, so now what I'm going to do is write the formulas. So right now I definitely have all compounds. So are they molecules, ionic compounds, or an acid? Well, it's definitely not an acid because it doesn't have the word acid. Is it a molecule? Does it have 2 or more nonmetals? No, these are all metals. So these are all ionic compounds, right? So ionic compound, ionic compound, ionic compound, ionic compound, which means I have to figure out the ions, reduce, crisscross. So aluminum sulfate, Al is 3+, and sulfate is one of my polyatomics. Remember, if you don't know your polyatomics, you can have your sheet. Sulfate is SO4 2-. So when I reduce, crisscross that, I have Al2 SO4 3 plus calcium chloride. Figure out the ions again. So I have, right, calcium, Ca2 plus, chloride, Cl1 minus, reduce, crisscross, right, nothing can be reduced, so I have Ca, Cl2, arrow, calcium sulfate, this one's going to be Ca2 plus, sulfate we already know is SO4 2-, reduce, crisscross, these cancel, I have CaSO4 plus, aluminum chloride will be Al3 plus and Cl1-. That gives me AlCl3. Now remember, with number 2, I have to also include the states of matter. So they're all aqueous, except for the calcium sulfate, that's solid. So I have AQ here, AQ, solid, AQ. So now, right, I have my skeleton equation, but now I have to balance. I'm going to be doing the balancing in this blue color. So now I'm going to do an atom inventory. I would keep the SO4s together. I think that's going to make it easier to balance. Remember, that's keeping the polyatomic ions grouped as one unit. So I have Al, SO4, Ca, Cl, and then write those over here. Al, there's 2, SO4, remember it's that whole group. This has 3. Ca is 1, Cl 2. Over here, Al is 1, SO4 1, Ca 1, Cl 3. So now I see that my Al is not balanced, my SO4, and then my Cl. My Cas are. So I could just start with the Al, right? So there's 2 here, 1 here. So then I asked myself, how can I get a total of 2 on the right side? I can put a 2 here, but that's going to change Al and Cl3. So I cross out Al and Cl. So now how many do I have? 1 is understood here. 2 times 1 is 2. Cl, 2 times 3 is 6. So now my Als are balanced, but now my SO4 isn't, and my Cls. So now what I can do is balance my sulfates. 3 here, 1 here. I'm going to put a 3 here. That's going to change Ca and SO4. Now there's 3 Cas, 3 SO4s. So Al is balanced, SO4 is balanced, Ca now, 1 and 3, I can put a 3 here. That's going to change Ca and Cl. So now remember, I don't look here, I look up here. 3 times the 1 here understood is 3. Cl, 3 times 2 is 6. Now everything's balanced, and that would be my final answer. Once again, this is the type of work that I expect to see on your homework. All right, there are 5 different types of reactions that we're going to study. Synthesis, which can also be called combination, decomposition, combustion, single replacement, double replacement. These 5 reactions are going to be applied based on what we learned in first semester. So this kind of gives you an idea of where we're going with all the nomenclature that we learned. So the first type is synthesis. Synthesis is when 2 things, A plus B, come together to form AB. So here's a good example. How do I recognize that it's a synthesis reaction? You're only going to have one thing on the right. That's called a product, right? So it has one product. So this is what you want to write in your notes on page 4. Synthesis has one product. Decomposition. Notice how decomposition is the reverse of synthesis. AB arrow A plus B. So this one has one reactant. Here is the reverse of the reaction above. Combustion. Combustion, right? Most of you will recognize that combustion means burning, but we need oxygen to burn. So notice how both these have oxygen. There can be elemental, hydrocarbon. We saw hydrocarbon when we were looking at balancing equations. For elemental, right, you're going to have an element plus oxygen giving you whatever forms on the right side. Special note, can also be classified as synthesis. So when you have elemental combustion, it's also called synthesis, and your homework will have one that has 2 answers for the type. So this would be a hint that it's elemental combustion and synthesis. How do I recognize that it has elemental combustion? It's going to be a reactant that reacts with oxygen. Remember, oxygen's a diatomic, that's why it's O2 here. Hydrocarbon combustion. So here I have a hydrocarbon which has hydrogen and carbon, and it reacts with oxygen. And if it's complete combustion, it's always going to give me CO2 and H2O. Here's a good example. So we've looked at types 1, 2, and 3. Moving on to single replacement and double replacement. Single replacement is when you have an element and a compound reacting to form a new element and a new compound. So notice here, element, one thing by itself, ionic compound gives us an element by itself with a compound. And we must use the activity series. We're going to talk about that the next day, not today. And how can I recognize it? Element reacts with a compound to form new element and compound. We're going to use the activity series the following day to figure out the products. But today you have to be able to recognize. Double replacement, how do I recognize double replacement? Notice how they look very similar. But the difference is that this is element and compound, this one's compound, compound. So it has two compounds on both sides. Notice ionic compound, gives us ionic compound, ionic compound. So what does our homework look like? Well, we are now going to look at 11.1, the back. So now we're looking at 11.1, the back. On 11.1, the back, there are 4 problems. Write the word equations below as chemical equations and balance. You must also include states of matter, right? So this homework should look just like these 2 problems. You're going to write the word equation. Then you're going to figure out number 2, which is going to be the skeleton equation with states of matter. And then the third part is balancing, and you can do that in a different color so that I can see every single step. All right, and then just make sure that you know how to use your flow chart and practice with this, but you will have a quiz in class. You will not get this. You get your periodic table and a list of the ions, and that's it. Okay, so make sure you have this for class.